Thank you for coming. My name is Steve Smith. I'm the editor of Ground Sport Worldwide. And today we're going to talk for the next half hour, taking a different road to green GSE. We're going to have to take a slightly different road ourselves since one of our speakers canceled out. But we do have some really good replacements for that gentleman. Brad Compton, Vice President of Sales and Marketing, is going to go first. He's going to talk a little bit more about the manufacturing perspectives of green tugs and tractors and all those assorted things. Brad did speak on the subject this morning as well. And then we will follow that with Brent Perry. He's the CEO of Corvus Energy, and Corvus is going to talk about lithium-ion batteries. So, let me welcome Brad. Brad, take it from here.
Thank you. All right, well, good afternoon. I would do a lot better with this if I had a beer in my hand. Anyway, I gave this presentation this morning, so if you were there, I apologize because you're going to see the same slides. And let me just fire it up here. Just double click. All right. How are we doing this here? We good?
From beginning?
Right there. All right. So anyway, the manufacturing perspective of alternate fuels, and I'm a marketing guy, so it's going to be all visuals for you here, but obviously the ramp, that's our playground. That's how we go about getting involved with our customer base. The input from them really drives on how we go about manufacturing and how we go about R&D and how we go about putting product out into the field. We're talking about batteries, we're talking about alternate fuels, and we always talk about that subject where we start with fuel prices. That's the main driver about how we talk about alternate fuels. It always comes up. And right now we're getting to the point where it's getting a little crazy for fuel prices. Also, lower maintenance costs. That's probably the second one you always talk about when you're talking alternate fuels. And then ramp air quality. This is a pretty drastic photo, but this is what people have in their mind when they talk about alternate fuels and how you approach the ramp and how you approach the equipment. So if you talk about GSE in relation to the production and the ramp operations, I think these bullet points are the main factors in how we look at that. The technological process and the innovations. You got to maintain your standards, offer differentiation, the right long-term strategy in line with the market needs and trends. I think that's awfully important as we look at the future and how we do things. And then the last one I think is probably the main driver, and that is forecasting. And that's always brought up in our meetings. That's always brought up when you talk to the customers. How can we get better in working with the customer base and us as manufacturers in forecasting and try to figure out not what next week might look like or the next month or the next quarter, but the next couple of years. And are we good at that? Not that good. So as a sales guys, you always want to have good forecasting. Sometimes it's lucky, but I always live by the one is, if you live by the crystal ball, you're going to eat broken glass. So, okay, the challenges. I think when you look at the challenges of GSE, you got to look at the different operations that are out there and how you're going to adapt to those. Each airline is going to be different. Each cargo company is going to be different. Each industrial customer is going to be different. And you have to move as rapidly as your customer base. And then from a manufacturing standpoint, you need to find a way to get some positive returns on your engineering investments. These are some of the cycles, or the cycle. You look at the emissions compliances, you look at the funding into electric vehicles, and then what's the available technology, how do you produce it, how do you test it accordingly. Again, from a manufacturing standpoint, you got to be flexible, focused, value added. And this one's interesting because we've been there, done that. We've been doing this for a long time. There was a time when we did a hybrid vehicle. I think it came out a little bit before its time, and you got to kind of swallow your pride, put the tarp over it, and start over. So there's a lot of R&D involved. Sometimes you want to rush to market for the right reasons, but you got to slow down and make sure it's correct. So you look at field testing. We've done many of these. I've done many of these. And I think the ramp feedback is awfully important. You got to get that feedback and bring it back to your office, and it's got to be data driven. Again, another manufacturing perspective. You got to be faster to market rather than slower to market. I won't go through all these bullet points, but this is just a way to look at the manufacturing perspective. Again, you got different clouds, you got different teams that got to work together. These are the development cycles. So you've got your marketing group, your R&D group, the supply chain, the sales, and engineering. They all have to work in concert to try to get to that main goal. I put a slide up here of our current frame for our electric tractor. And what's interesting about this is when we developed the first tractor, we developed it and then tried to figure out where we're going to put the damn battery. Now we got a little smarter, I think, for all our manufacturers. We designed it around the battery, low center of gravity, and you move forward. Again, you got to demonstrate your new products. That takes a lot of effort, not only from the manufacturer, but I think the customer. And again, you got to have that right data. And this is where the operations come into play. And this is where we as manufacturers need the feedback to go forward. Manage the operation with proper GSE and infrastructure is awfully important. You got to allow for the proper maintenance. You got to monitor it. You got to monitor your fleet averages against the regulations. The carbon footprint. Just a couple of quotes. Again, as you're out there, you hear that wide bodies, you need about 50 pieces to support a wide body. What % of that can be alternate fuels? The cost of compliance, diesel, gas, LP, and also electric, which is the proven. You've got the Vail and iLive that are out there. You got the regional differences, standards, regulations, technology, and operations. Just another couple of items to think about in terms of internal combustion and how much diesel they put out each year or per product. And I think GSE has reached maturity, and it's an easy target for the grants and easy targets for going alternate fuels. So we start talking about state of the art, and I think that's a good segue into Corvus and what they're doing with lithium. You also have the hybrid and the electrics, which are proven. These are some numbers, just average numbers. I'm sure there's plus and there's going to be minus to this, but if you look at about 75,000 of the units by fuel type, it's still driven with gas and diesel, with electric being about 10% of that. And this is a worldwide look. If you look at what TUG's standpoint is, obviously we're still driving a lot of internal combustion, diesel, gas, and then the TUG MZ is our electric product. That is also combined with our electric belt loader. So it's still a small piece of our pie. And then you got to tackle the cost and the challenges. This here is a little crazy, but it kind of gives you the wordsmith into what's going on in terms of how we operate from a cost standpoint for manufacturing and some of the challenges we're faced against. And I highlighted the two, which is inventory and forecast, because I think those are directly related and awfully important. That's it. So again, from a manufacturing standpoint, there's many factors that go into it, but the one slide that we talked about, state of the art, again, good segue into Corvus and what they're doing, and we'll leave it at that. So thanks a lot for your time. Appreciate it.
Thank you, Brad. Before we go to Mr. Perry, talk about lithium ion, I wonder if anybody had any questions about what Brad just talked about. Well, I was just curious about one thing myself. We had Claude Pepin from Can-Am Motive was going to talk originally about hydrogen-powered tugs that he's had tested at Air Canada last year. And then as he dropped out, I was looking for some alternative sources of green, and I thought about propane. Now, I know there's a lot of buses that'll take you to your parking spot, or the rental car that operate from airports, but I really didn't think there was too much application for propane in GSE. Is there anybody that's got any kind of history in using that at all? Nobody? All right. All right, well, we'll jump to Mr. Perry then. Brent Perry is the CEO and president of Corvus Energy, and he will be talking about lithium-ion batteries.
Hi, everybody. Can you guys hear me okay? Great, thanks. As mentioned, I'm the CEO and president of Corvus Energy. Corvus Energy is basically an energy solutions company, and we base all of our solutions on the lithium polymer batteries that we manufacture that you guys can all take a look at over there. Give me 2 seconds here and I'll pop up our presentation. My discussion today is really to try and clear the decks with everybody here in terms of understanding some of the pluses and minuses of lithium technology. If you guys have any questions, please feel free to interrupt me during the presentation if it's an appropriate moment for you, or if you'd like, hold the questions until the end. Okay, so as I said, we're going to address the advantages to start with, then we'll go into the disadvantages of lithium, current trends and market needs of where the lithium industry is actually going to go, and how that's going to be incorporated into the future business of GSE. One of the biggest things with lithium battery systems is understanding that there is apples and there is apples and there's apples, and not everything is the same. I'm going to be addressing this specifically from the point of view of what we manufacture, because that's really what we've spent all our time turning into the kind of product that will suit the GSE business. But I'll give you a very brief history of our company to start with. We come from the non-battery world, if you want. Our expertise lies in applications engineering and solutions engineering. And several years ago, we had clients coming to us looking for hybrid solutions for large-scale marine applications like tugboats and ferries and oil and gas rigs and things like that. And so we investigated the world as what I would call technology agnostics. We had really no loyalty to any particular battery chemistry or style or method. Our whole focus has always been to satisfy what is the customer's needs and use the best product to meet those expectations. And frankly, in the last 6 years, everything that we do has been driven towards what is the right solution for the customer. If we don't have it, we don't try and sell it. The other feature of our business is that we're very cognizant of the reality of the fiscal part of our business, so we don't even address solutions that have less than a 5-year payback to them. So everything is driven around the reality of how businesses run today and what they can do and what they need to do, and then about addressing the product solution around what is the best thing for the client to use. We entered into this business the way we enter into all of our businesses, in that we had a lot of pull from the aviation industry. Our very first customer was WestJet Airlines, which are based out of Edmonton and Calgary up in Canada. And they came to us looking for an electric solution for the GSE equipment, and very particularly the bag handler and the belt loaders. That started a relationship that allowed us to learn from their level of expertise at operations and ramp duties, and incorporate all of the features that needed to be part of the GSE solution into the bag handler and belt loader that we built for them, and allowed us to bring our expertise in terms of being applications and solutions experts, and let the battery, which actually is extremely suitable for this application, become part of that integral solution for the GSE equipment that you see here today. So it's an interesting road in that it wasn't us going into this business and looking at it and saying, does it make sense? It was driven by WestJet coming to us and looking for the solution. But what we've discovered through the process, that not only could we deliver a fantastic technical solution, but that really the metrics of the business model within the GSE world, and in particular to start with WestJet, made a lot of sense for them to look at translating their whole fleet over. And we've been moving down the path with them ever since. It's been a very good relationship and a lot of fun, and we really appreciate the expertise that they brought into our company. Now, one of the things that was an initial concern with WestJet, and is with everybody that we deal with, is safety. Lithium has, let's call it, a poor reputation. If you go on YouTube and look up lithium, you'll see tons of little lithium fires and explosions and bombs and all of that sort of stuff. So when we started back in 2006 addressing these kinds of issues, safety was the number one concern that we knew we had to go reach out to our commercial customers and address 100%.
Once again, ladies and gentlemen, if we have time, please stop off at the Devil's on Demand.
So elements of that safety became what we'll see a little later on here. You'll see one picture here on this slide on the bottom right-hand corner is an actual line diagram of our battery management system. That battery management system has every single element of it is incorporated into redundancy and safety. So even if we have a dead short across a module, our BMS will still maintain functionality and still have, if you want, control of the safety features of the battery. And there's duplicity in the sense that there's two processors that are principally operating the battery pack and the interacting with the system. If one of those processors fails, the other one can take up the work of that processor, the program to do both, so that effectively we'll know that we have something we have to address, but we're not going to compromise the user's ability to make that equipment work and function all the time as it goes. Now, some of the other, I'll get more into the safety as we go through this. Some of the other features of us, we went, as we were technology agnostics, we spent a great deal of time testing cells. I visited over 30 different factories myself. Between my partners and I think we've been to nearly 100 factories. What we would do is take cells off the end of everybody's production line and physically test them. In the boat building industry, you believe what you touch. You don't believe anything else because nothing else is real. So when we did this, what we discovered that while there's excellent chemistries in the world today, the ability to translate from the lab into a manufacturing process isn't always the same. And there are very great degrees of quality up or down between different cell manufacturers. Through all of this, we had our end user customer in the marine industry in mind, and we eliminated almost all of the cell manufacturers that we tested as being suitable for what we were doing in the marine industry. We ended up with a company called Kokum, which is based out of Korea and is now also based in the United States. Now has become a merged company with Dow Chemicals to be called Dow Kokum. Quality is very important to us, and so it's not about the quality of what this one cell that we test, it's about the quality of the manufacturing process and how it's able to deliver to you consistency over and over and over again. In lithium, the best battery in the world is the most boring battery in the world. Everything about it is consistent and never changes. Reliability is another feature for us that's 100% critical. Our operators are people whose lives are at stake with the equipment that they're using, so the battery had to be able to work and function with the ability to defend that reliability and support the life applications that we're working within, whether it's a military application, a commercial vessel, even in GSE equipment. I think the same applies. So we had to have something that could deliver 365-day-a-year reliability to our clients. Long cycle life is very important. The cost, and this is more related to cost than it is to performance, but one of the things that makes GSE make sense with lithium is the fact that there is a payback, and that payback delivers for a long time, so you can have operational savings over the whole life of the machine. If the lithium battery only lasts for 2 or 3 years, there's no opportunity for it to compete with something as inexpensive as lead acid. Even though it's a much better performance battery, it wouldn't make any difference. So long cycle life was critical, and we focused a lot of our development of our battery management system at how to optimize that long cycle life of a very good cell at the beginning of the process. The other issue for us in the marine industry, you have to be 100% sealed. You're working in a saltwater environment, you're working at a tremendous range of humidity, you're working in a tremendous range of temperature, typically from 40 to 55 degrees Celsius, and you have to have absolute integrity of that box. So our boxes are all manufactured to a standard called IP67, which means effectively they can run submersed. And it was very important that A, we couldn't open the box, and B, very important that there is no opportunity to do maintenance. So we had to make a battery management system smart enough that it would communicate with us and make sure that we understood if the battery was having a problem and needed to be replaced at some point in the near future. And back to the safety side of it. In most battery systems, there really is only one level of safety, and that's a DC fuse between the end of the battery and the DC bus. So that is typically what we're all used to dealing with lead acid systems. And we realized and recognized, because of the reputation of lithium, that it just wasn't good enough to stop there. So what we've done is we still have you still have a physical breaker or a fuse at the DC bus, and then internally you have a set of a controller that has contactors. The contactors perform a couple of features for us. One, they help us to manage the charge and discharge of the battery because they'll engage and disengage it off the DC bus as required for that. Two, they are an added safety feature that again allows us to either engage or disengage from the ship or the system or the vessel or the machine, depending upon what the information it's getting from the other half. Three, we had to have our battery management system able to program any level of safety specific to the application. A bag handler and a belt loader, they can both be electric machines, but they both have completely different duty cycles, and so the battery management system has to be programmed to optimize each one of them a little bit differently. The only thing that we, if you want to call it customized in our battery manufacturing process, is the programming to make sure that the operation of the battery is optimized for whatever machine it's going into. The other added feature is that we can program these remotely, so that if something changes application, if you move a battery from one machine to another, you can quickly change the duty profile of the battery as well to make sure it functions exactly as it should within the scope of that machine. And then the last level of safety on this, and you can see the picture on the lower left-hand side, is that every positive tab on our cells has a thermal link, a thermal fuse. So inside our batteries we carry 24 cells, so we have 24 internally fused cells. Again, the only battery technology in the world that's able to do this. You simply can't do this with lead acid. And we can do this without compromising the charge-discharge efficiency of these batteries. In this case, we're dealing with a module that has about 99.2% charge-discharge efficiency, which means that basically all the energy that you put in and take out is what happens, and there's very, very little left for residual heat. And because we don't have a lot of heat to manage, that's one of the key features of why we have such a long-lived battery and why thermal management for us is such an easy feature compared to something like a lead acid or even quite a few other lithium chemistries. The other thing that really was one of the features of working in industrial applications is temperature range. Lithium chemistry typically works from 0 degrees Celsius all the way up to normally 50 degrees Celsius. The NMC that we use with the Dow Cokem cells has a broader temperature range and tends about -20 up to 60 degrees Celsius, but -20 isn't good enough for the environment that you guys work in. We have to be able to operate down to -40 or even -50 degrees. So, or at least on the Canadian side of the GSE world. So we used Calgary Airport as an opportunity to optimize our internal thermal package within the battery to maintain the core temperature at the point where it was always allowed for a good charge-discharge efficiency. So the core basically stays no colder than 0 degrees Celsius, but it maintains that while the external temperature can be as cold as -55. So the external environment doesn't affect us so much, and it's about making sure that the battery's at a good heat so you can go and turn the keys on this thing at any time and it will function for you without damaging the battery bank. We were very successful in proving that point when we had the vessel at Calgary this year. And you can see here also on this picture of a cell, this is a 100 amp hour cell that's being discharged at 200 amps at 4 volts. That's a tremendous amount of power being pushed out of this thing. It takes 30 minutes to fully discharge this cell, and over this 30 minutes there was about a 2-degree change in temperature on the cell itself. It just speaks to the quality of the cell. In many cases, if we tried to do a 200 amp discharge on a 100 amp lead acid battery, you would have in about 15 minutes a very nice event where you'd have a boom, the box would dissipate into lots and lots of pieces and would be what we call an active failure. This kind of technology can manage this very easily. It's part of how we do business every day. The batteries themselves can discharge up to 10 times the capacity of the system, and you can do 5 times the capacity of the system continuously, and we can charge at 2 times the capacity of the system, which means in 30 minutes I can go from full zero all the way back to 100%. The other point on here is about the rugged aspect of the battery systems. You guys live in a really demanding physical environment. There's a lot of work that has to be done. There's a lot of vibration. There's a lot of impact. People describe people who drive GSE equipment as 18-year-old blondes. I've physically seen that is absolutely the truth. And I would like to say that these guys have been able to creatively try and destroy machinery in ways that I never would have been able to imagine. So it validated for us what we did in terms of our casing and our core, and that we built something that was tough enough to withstand this kind of environment, and parts aren't going to shake loose and fall apart while we're doing this. To give you a note, the HE5 axis vibration is twice the standard expected from the U.S. military and all on-road vehicles. 6G will kill a person if we get into a vibration situation in that. So this is designed to give this product the stability it needs to last for 20 years. Now, the other feature, which is I think both a blessing and a curse on a battery system, is the fact that they're intelligent. In this case, these batteries are designed to protect themselves. They're designed to be programmed to meet your specific needs in terms of how they do that, and they're also designed to optimize their life and be used in a way that you can see the battery functioning and working all the time. This is Corby, by the way. He's our little battery mascot at Corvus. At the upper right side shows that we can actually do data logging within the battery itself. So we can either do a hard drive external to a battery and have the data transmitted via that, or internally, anytime we work outside of our parameters, we can data log that event occurring. So if there ever is anything that we need to analyze, we can go right back to the source point of the data to make sure that we understand where that failure is going to occur. To be fair to us in this capacity, we've never had anything but a forced failure in the field that we've developed ourselves. This is an extremely reliable technology and product. The other part of it, which is extremely useful to you guys and something that no other battery system in the world does, is that we can literally forecast the life of the battery. So we do that by analyzing everything on a cell-by-cell basis, and it will tell you if a battery has an anomaly within it, how long it's going to take for the battery to fail. That allows, from a maintenance point of view and a servicing point of view, it gives you guys a tremendous advantage of knowing that whenever you bring this machine in at some point in the next 4 or 5 months, we're going to have to change a module. It reduces the cost of this kind of exchange for everybody and means that we can actually all count on these machines to work 24/7. Some of the other features of our battery. Battery is virtually 100% recyclable, 99.4 or 5%. There's only a few elements that we can't recover during the recycling process. We recycle the batteries for our clients. So we can either take them at the point where they reach 80% of their original capacity, which is what most people will call end of life, or we can help our customer reuse the battery into something that's maybe non-performance demanding, like emergency lighting or something like that, and you can literally keep it in that application for many more years, and then when it's finished with that, we'll take it back and recycle it on your behalf. There is no emissions or gassing from these batteries. The cell themselves are vacuum sealed. The battery casing, as I mentioned before, is IP67 rated. It's fully sealed. So these batteries are as safe as you can possibly have and can work in any environment without impacting and without any special ventilation requirements at all. We install these literally in megawatt-sized capabilities on board large-scale ships like tugboats and ferries and workboats. And even in those cases, we don't have to do anything special in terms of ventilation or prevention within the battery spaces themselves. The other thing that's really critical about lithium batteries as part of the energy density value that we bring to the table is that quite literally you can use every watt hour that you have within these batteries. We have many different discharge profiles depending on how long the life of the system is going to be. But when we tell you you have 6.5 kilowatt hour or 13 kilowatt hour capacity, you have that capacity. You don't have to wait for a battery to be halfway dead and then go back and recharge it. You can use it to its full capacity if that's what the mission profile is, the best economical way to do it. The other part of it is that we are very much a talk-the-talk, walk-the-walk company. Ask anybody who's ever been to our factory. It's a very professional organization, and we support our product 100% with the best warranties that are available in commercial industries today. 8 years, 100% replacement on GS equipment with a prorated 8-year after that. And then basically we have that you're getting 16 years of support from us on our product. Again, mentioned earlier, this can recharge in 30 minutes. The issue there simply is, do we have enough power at the plug? That's almost always the issue. In the case of what we did with Calgary over the winter, we averaged about a 1-hour recharge time with the batteries from 100% discharged, and that was really a limitation of how much energy we had at the plug that we were using. The other important feature, I think, for everybody in this business, this is going to be, by June, a wholly North American-made product. So every part and piece inside of this comes from North America, either Canada or the United States. And that, I think, is a significant feature and an important one given the economic times everybody's working through right now. And here's just some examples of performance. This is an application on what's called an RTG, or a straddle carrier. This carries containers around inside of a port. And that machine basically is picking up 40-foot containers from where a ship drops them off, taking them to an 18-wheel truck and dumping them on the flat, and then going back and getting another one. This is a 24-hour duty cycle from that machine, and it's literally operating at a 4C, 2C rate, which means it's continually discharging 4 times the capacity of the battery bank and taking on 2 times the capacity of the battery in charge. We also take regeneration from the containers being dropped, and that, believe it or not, supplies about 20% of the power that this machine needs to run every day. This is an extremely demanding work profile. And yet, during that demanding work profile, here is our voltage and temperature profiles within the battery. You can see across the top that the voltage stability was very good. You do get peaks and demands as the things are being picked up or dropped. And then the blue line across the middle is the temperature of the bus bars, and the red and yellow lines, and I hope they're that color on that screen, are the temperatures at the positive points on the cells themselves. So this is something that's going through an application use that will kill most batteries in the world today. It's not even making us blip more than a couple of degrees during the whole operation. We started this at a day it was average about 32 degrees Celsius. Went down through a couple of different ranges of temperature. Now, the challenge is, because so far everybody usually gets to this point and says, yeah, it sounds way too good to be true. And in certain ways it is, because it is a very disruptive technology that does answer a lot of the problems that you guys have today with electrical equipment. One of the challenges it does have a computer on board. And a computer is a computer. Even though this is a military-grade computer, we have to understand the fact that that's a point of failure that could happen. Lead acid being a dumb battery technology sometimes is not a bad idea. There's applications where I wouldn't do this, but in most cases, the computer is what enables the battery to function the way that it does. Shipping costs on lithium batteries can be high. Typically speaking, we can't air transport these batteries. They're over a specific weight relative to lithium, and they ship as a Class 9 hazardous good. We account for that by having manufacturing capability that we can literally put into a 20-foot container, take to a site, and do the assembly, installation, and commissioning the batteries for the customer on their location. But there's always going to be an issue where a warranty battery has to be shipped or something like that at some point in the life of a product, and you're going to have to account for the fact it takes a little longer to get there simply because of the rules and regulations we deal with every day with shipping. The biggest barrier we've always seen to this technology right now is simply cost. 2 years ago, lithium cost 3 times what it does today. The product is seeing a huge fall in the price of lithium, but that doesn't make it any easier to swallow today. Although what we can successfully show when we come into an application like GSE, we wouldn't be in here if we didn't have that 5-year payback. And in the case of GSE equipment, every bit's a bit different, but anywhere from 2 to 4 years is very realistic on payback on this. And you're dealing with a machine that's going to last for 15 to 20 years. So what you're looking at is a very good CapEx, OpEx model, regardless of the fact that it may cost a little more money up front. The other feature is that part of our business and part of everyone's business here is that we go around the CapEx cost issue by being able to put it into a leasing model or a rental model or something like that that allows us to pay for it as we use it effectively and gain all of the value and performance of the lithium battery, but only do it at a fraction of the upfront cost of what you do today. The other issue is that, simply put, there is not that many successful lithium battery companies that have got a long track record and history of putting batteries into the field. So everybody's other question is, well, are you going to stay in business long enough to do this? You guys have all been victim to many different new technologies over the last few years. You've seen fuel cells come and go. You've seen other lithium product come and go. You've seen different versions of lead acid batteries come and go. And what you need is stability. And we understand that. What we bring to this is one of the only companies that's been in business for a long enough period of time, building and delivering successful commercial products. And our parent company, or shouldn't say parent company, our partner company in Dow Kokum as a self-supplier, has also been in business for a long time, delivering things to military applications and life science applications. So what we have is probably the best track record in the industry of actually delivering working commercial solutions. And what we can bring to you on this is that what we can do is every year reduce our costs as we move forward in this industry to make it more and more viable as the cost of lithium continues to fall. And we can continue to deliver the quality product that is exactly what you expect in terms of having something you can rely on as a partner every day. The other concerns people have had is the fire and explosion capabilities. Now, in our case, lithium is not incorporated into the battery in any which way, shape, or form. It's a lithium polymer, which basically means you don't have any active lithium metal. Lithium is like manganese. If it gets exposed to oxygen, you have a fire that is like a birthday candle you can't blow out. It's exactly the same way. And almost every method of firefighting with a lithium metal battery will literally just extend the fire. With the polymer system that we use, we can use simple CO2 extinguishers to put out a fire if one ever did develop. But frankly, we've designed and engineered around the battery well enough that a fire or an explosion is almost literally impossible to occur. We shoot these cells on a monthly basis. It's a lot of fun. You can come up to my farm and go through that experience with me if you want to test it. We burn them. We crush them. We basically treat them like someone you'd never want to talk to. We run over them. We do everything we possibly can to cause accidents or what I call active failures within the battery. All we're able to generate with all the safety systems that we have built into the battery are what we call passive failures, i.e. the battery will fail, it will distinguish itself in terms of energy, but it literally is, I wouldn't say impossible, but it's very difficult to go past that as an active event. The other thing that is really important to understand about lithium is there's probably altogether, I think there's 12 or 13 different chemistries. So one lithium battery is not the same as another lithium battery. And within each chemistry, there may be one or dozens and dozens of people who manufacture the cells. So the difficult thing for you to do as industry people looking for a solution is to really wade through it all and come out with what is a good or a bad solution and make sure you're satisfied. All I ask you to do is focus on the relationship you have with the companies that you work with. Make sure that there's a lot of clarity. Don't deal in a vendor relationship with people like ourselves. We're much better as partners. Work with companies who want to take your best interests on, deliver solutions that meet your needs with you, and support you not only at the time of the engineering and the sale, which is only about 1% of a relationship, but are there for you and committed to supporting you over the life of the equipment that you have. It's really important, and we don't see this as a short-term relationship. This is getting married, and we're Catholics. We're not allowed to get divorced. Now, to talk to lithium trends and market needs a little bit, one of the things we talked about was price. As I mentioned, when we first looked at this business back in 2006, the cost of lithium was close to $10,000 a kilowatt hour. Our batteries, and I have two of them in most of the equipment we have here, there's 13 kilowatt hour, which means the battery cost on the lithium would be $130,000. Since then, the price has literally just tumbled. And partly because there's been so much support at the government level in North America to develop manufacturing capability for the cells, we've now created a situation where there's an overabundance of capacity, and the price is going to continue to fall literally like a rock through the floor. And we've crossed the threshold where we make the 5-year payback models. Now we're working towards a threshold where the payback model can be even within a year. This is something that all the U.S. manufacturers are threatened with right now, though, too, is that they have an overcapacity and they don't have anywhere to put the cells. Most of them have focused on developing the manufacturing part of it. Sorry about that. Very few of them have focused on applications. And what I do, and there's many other companies like us at this point, is we bring the expertise of the application to the cell manufacturers so that we can work with them to integrate the solution into something that really works. But still, what's happening is for the next couple of years, this overcapacity is going to be a real issue and challenge these companies to stay in business. Now, the other thing that's kind of fun and unique about lithium is that with every marketplace it enters, it dominates. Eventually, as the price points come down, everybody goes to lithium as a solution because it simply is the best battery solution available in the world today, barring economics. Whether we're talking about your cell phone, whether we're talking about your car, whether we're talking about your electronics, everything is powered by batteries today, and more it's trending towards lithium batteries. Now, the challenge is you can't look at it today as a CapEx issue. You really do have to be able to open your mind in terms of business and see it as a CapEx, OpEx issue. Because lithium really comes into its own in the fact that it is a long-lived product and it is going to bring you a lot of return over that lifetime. If you can't look at it from that point of view from a financing side, then this product will never, ever make sense to you, not for the next 5 years. If you can look at it from a CapEx, OpEx point of view, you'll see that almost initially you can start operating with lower costs and saving money, even paying for lithium on an annual basis. And I'm not talking about carbon credits here. That's a totally different source of revenue. We're just talking purely about the actual operational benefits of how lithium batteries interact with your machinery. Here's just, if you want, the curve that lithium batteries have taken over the last 25 years. They started out in very small RC-type plane applications where batteries were about the size of the tip of your thumb. That's what you see exploding on YouTube all the time. Moved into things like cell phones and power tools, and today dominate both of those industries in terms of batteries. Have now become the dominant supplier and support for laptop computers. As we've all seen over the last couple of years, they're moving very actively into the automotive market space. Then companies like us have taken them into very large-scale industrial applications like marine applications and tugboats. In this case, in something like a tugboat, it's very similar to GSE equipment. It saves enough money in a tugboat, even though we're putting a 2 megawatt hour or a 3 megawatt hour battery into this, to pay for itself within 5 years. And the environmental benefits, for us, that's icing on the cake. We're very glad that they're generated, but it's not the reason these guys are doing this business. They're doing it to reduce their operational costs. And then finally, we're getting to the GSE equipment, which you guys are seeing here today. And it's just been a really fun ride to work with you guys, and I hope we have the opportunity to work with you all again over the next few years. There's a picture of one of our batteries. This basically, you can see the guts and how this is set up. This is also over at our stand. And it's fun in the sense that it kind of looks like a Terminator model or something like that. But you can see the ruggedness, the durability, and everything that's been built into this from a quality point of view by the simplicity of how we put these together and how they work. Everything that we do is a little bit over the top, but we do that because we know you expect to have 100% reliability in what you do. Thanks very much for your time today, guys.
questions for Mr. Perry? Does anyone have any questions? Yes. Sorry, we have a handheld mic somewhere.
You talked about fuel cells for a bit. What do you think about them being used in GSEs?
Okay. Let me repeat. So the question had to do about fuel cells and
Fuel
the use of
cells
GSE.
in GSEs, yeah.
Sure. Well, every product, whatever it's designed for, has an application. In my mind, our battery is not perfect for every application, it's perfect for some. Fuel cells are the same. I think that if you can balance a fuel cell, frankly, fuel cells work very well with batteries because the fuel cell isn't necessarily as voltage stable or as hertz stable as you'd want it to be in an application, and a battery acts as a fantastic filter for those systems. We work with many fuel cell companies today to produce products for exactly that reason. They're an excellent source of energy. It really does come down to the optics of the industry. Can you install a hydrogen system to support the charging of the fuel cell at an airport? How much does that cost? How much does the fuel cell cost? Does it generate that 5-year payback or not? Performance, I don't think, is an issue. The machines work. The issue is really, do they work cost effectively enough to be adapted within the industry today?
Anyone else have any other questions? Well, I have a question for Brent. I wonder if you could talk about the costs associated with lithium-ion and GSE, payback, that sort of thing.
Sure. Relatively speaking, if you go look at what we have over there today in terms of kits for the bag handlers and the belt loaders, the starting kits right now on a retail level are set up to be about $25,000. What we call heavy-duty systems will cost anywhere from $35,000 to $45,000. The payback on a $45,000 system, it's largely related to work. How much does the machine work? If you only work 500 hours, then it's the wrong system for you to use. It will take 15 years to pay itself back. If you can work 2,000 hours a year on that machine, then the payback comes down to somewhere in the 3 to 4 year neighborhood. So what we encourage all of our clients to do is come to us with the idea of what is your business model and how does it relate to what are the economics of the machine. And half of what we do at the initial stages of a relationship is really understand the economics and see if it does make sense at all today. If it doesn't today, then it may make sense next year or the year after that as the prices of these kits fall. But the whole focus of this is to put something in your hands that makes economic sense for you today, meets your needs, whatever they are corporate relative to the environment and to giving back to the community, and allows you the opportunity to have something that's more reliable and less maintenance than what you're dealing with as current product. And that simply is how we manage the execution of our business. So in the best case, if you're using a 1 or a 2 battery system hard, you're going to see payback from 1.2 to 2 years. And in the worst case, it'll be 3 to 4 years. Does that answer your question? Okay.
Where's your booth, and do you have any equipment that can be tested?
As my director of marketing has very succinctly reminded me about what we're doing here, we do have 2 machines that are in the rodeo that you guys can test ride, and I encourage you to go and try and break them. I think what you'll find is that you'll get more frustrated and maybe even get a bruise or 2 while you try and abuse the machinery to that level. And over at our booth, which is booth number 1825, we have a belt loader, which is our alpha belt loader, and one of our bag handlers there as well for you guys to be able to inspect all the machinery. We are what we call a totally open book company. Please feel free to ask us any questions. Even if you happen to be a battery manufacturer or another GSE equipment manufacturer, we don't really think there's any secrets in this business. It's all about how well you execute what you do.
All right, anyone else have any other questions? I actually have a question for Brad, who incidentally is in booth 2023. Now, Tug Technologies would be very happy to sell you a brand new Tug, of course, but they also offer a very extensive refurbishment plans, programs with their Tugs. And I just wonder, Brad, if someone's swapping out a fossil-fueled engine, what are they switching it out to? What's the source of power going to be?
Well,
I think that's becoming awfully popular now, and for the right reasons. To take, if you want to call it the dirty diesel or an older internal combustion, a lot of people are doing it, and Tug is also doing a good job at it. And you could look at it a few different ways. We've taken diesel, converted a belt loader to electric. We've taken gas and upgraded it to a Tier 3, Tier 4i engine to get it cleaner, to get the average where you need it. So to answer your question, yeah, there's many ways to approach it, and yes, you can do it if it's the right product and it's the right fit. Obviously, you got to make sure things are lining up in terms of the transmission to the engine, but yeah, it's becoming popular, and I think it's in certain circumstances the right move, both in terms of economics and in terms of faster to market, because sometimes we are challenged with how quickly we could get our suppliers motivated to bring in those axles. If you can reuse an asset and all you're doing is reusing the steel, that's a pretty good idea. So yeah, you can go to electric, you can go to LP, you can go to a cleaner engine. Many different ways of doing it, and there's many people here showcasing that. So you can come by the Tug booth and talk to us further about that too. So that's it.
All right, any other questions? Well, if not, thanks for coming. Thanks, Mr. Perry and Mr. Compton.